So if you want to take your seats.
Уважаемые господа, прошу внимания. Мне выпала большая честь представить модератора следующей нашей панели. Это господина Уильяма Герстенмайера, представителя центрального аппарата НАСА, заместителя руководителя НАСА, начальника управления программ пилотируемых полетов и операций, ну, в общем, большого нашего начальника, который уже работает в НАСА с 1977 года, занимался сначала, так сказать, вопросами авиационных исследований в центре Льюиса. В дальнейшем работал по
He's been working with aviation research, and later on he was working with manned missions. I am especially pleased that Mr. Gerstenmaier was one of the leads for Shuttle Mir, NASA Mir programs. He was coordinating operations with the Russian Space Agency. He was responsible for coordinating scientific activities for the crew. And at that time, we realized how businesslike and how helpful and knowledgeable he is. Since 1998, as a lead for Space Shuttle program, he was an administrator for the latest shuttle program. Last one, Mr. Gerstenmaier has a B degree in technology and machine technology. He's from Purdue University, and he is a recipient of numerous awards, including the one from the President of the country for outstanding achievements. And it is a great honor for all of us that Mr. Gerstenmaier is going to be our moderator today. Welcome.
Thank you very much, Valery. It's tremendous to be introduced by you. We're going to do things a little differently with this group. Instead of us going down the line and each group, each person giving a little short vignette of the topic, I'm going to turn it over to the audience and you're going to ask questions. So we're turning it around. You think of us as the audience. And if you don't ask us good questions, I'm sure this astute group of who I know up here is outstanding. They will ask you good questions, and then you will be on the hot seat. So we'll see how this goes, but we'll go through this. Our topic today is really maximizing scientific return from the integrated use of facilities and crew. So if we've kind of touched on that on several of the other panels up front. We've talked a little bit about why it's important to do integrated activities to maximize return. Valery gave a very good discussion of that in the last session. So we ought to think about that, but then how do we take this from just kind of an academic discussion and how do we make this into something that we can really go execute? We've had this topic several times before. So we'll go ahead and do that. We'll talk about sharing facilities, results, and inventory, and we'll talk also about sharing crew members and data back and forth, which I think is tremendously important. So with that, I'll see if there's any questions or any comments on this topic, and then you've got a great group here to answer questions for you. So we'll go ahead and I think I saw a couple hands here.
At the coffee break, Rupert Gertzer asked me why I didn't ask about artificial gravity. So here we go.
All right.
So I believe everybody here understands that if one is to go and assess any countermeasure for long-duration use, we must, absolutely must, verify its validity and acceptability in long-duration weightlessness. And the only game in town is the space station. And various people, including many people in this room, have done ground experiments with short radius centrifugation. There have been proposals and attempts to do a demonstration or feasibility studies on the space station, which has run into some difficulties. And I would like members of the panel who wish to respond to the need and the practicality of doing artificial gravity demonstration experiments on the station.
Okay. So Rupert, since you got this started, you're going to have to answer this one.
Yes, I think it was clear from the last panel, and therefore I asked him that what we need for the future is something very simple. It's a countermeasure, doesn't take a lot of time, is fun, and works. So it's an easy task, and many of us think that an artificial gravity could be a solution, and therefore many of us are working in this topic. The Americans are working. We have one. We get a second one at my institution. The Russians now, IBMP has one. So I think the time is kind of mature to go on here. And but I don't have the answer. The answer for me is we have to go on because it looks logical that artificial gravity has a great potential. I don't know whether Inessa or somebody else also wants to add some things.
Yeah. I see two places that might be ripe for adding artificial gravity. One might be in your sleep station, where after you go to sleep at night, you could have a short arm centrifuge where maybe your head is close to the axis of rotation, and you just sleep there during the night. The other possibility might be on your exercise bicycle. Make your exercise bicycle so that as you pedal it, it spins you around like a merry-go-round, and that way you get your exercise accomplished at the same time that you can subject yourself to as much angular acceleration as you possibly can stomach. And so that might be two places that would be ripe for adding an artificial gravity. I think we're a little ways away from spinning the whole spaceship like in yeah.
Well, Don, once again, we're in violent agreement. Peter Diamandis, who I think many of you know for X Prize, did his thesis for us showing that you could sleep in artificial gravity, and he had people on the centrifuge. And then I think almost all of the AG designs include bicycle or some other kind of exercise with it.
Okay.
I think I can say at the comment, if we can just utilize the crew sleep time for artificial gravity experiment, then we can maximize the science output because we can use the sleep time.
Yeah, we could be doing science in our sleep. Now, Gers, could
now
we...
you heard that here on this panel. We're going to do science in our sleep. Write that down.
Could we count that towards our number of utilization hours?
We can do that. We could definitely do that.
Sleep all day, too.
Graham?
Yeah, so Larry, there's actually an interesting precursor to this, and that's artificial gravity with cell culture and with model organisms. So if you think about what the really well-designed experiment you'd like to do with, let's say, mice or rodents or other model organisms, you'd actually like to be able to have a centrifuge on the International Space Station, so you could control. So you'd have a
such
control.
Experiment were provided during our satellite flights. We have the program in Russia of satellite flights with animal on board, which are coming back, and it was in 80s, 70s and 80s. They were flown rats, some of which were just in weightlessness, and the other were rotated in the centrifuge, And the rats which were centrifuged during flight, they came to the ground, and they were flown by 19 days and 30 days, and 19, not 90, 19, and yes, and 30 days, right? And those who were centrifuged, they came with very good results. Their muscle and bone were in very good condition. However, they had different difficulty. They were discoordinated completely. So you know the human body is very complicated organism. So you can help to one system, and you can you can somehow bring harm to the other ones. So that is necessary. That's why I support what Larry said, that we cannot say, let's put, like Donald said, let's put tomorrow and let them sleep during centrifugation. First of all, they would not sleep if you will centrifuge them with that proper, parameters which are needed for efficacy. They will not sleep. And the other thing, we have to work on it on the ground. And I'm sorry that I'm like that cuckoo who say again and again that whatever what we can do on board, that's great. But why not to use this moment when we started to prepare for long-term flight? It's like no new phase in our life to make very broad on-ground experimental sessions and so on, and whatever we can do on the ground, do it, rather than put everything on our cosmonaut in flight. Let us test in flight whatever necessary to test there, but to develop the program for centrifugation. Larry, you already started this. You made the very first experiment, but it was just first one. So,
Okay.
Bill
All right.
is here. So 2 of you are here. So you started and you stopped. You stopped because you didn't get immediate results. Like, there are no immediate results. Always you have to develop, and that's it. But so I think that the artificial gravity, it will be very good addition to countermeasure system in long-term flight. Maybe necessary, but we have to work on it.
Okay.
That's what I would say.
All right. We got another question somewhere? Yep. Here.
Yeah, this maximizing discussion that you're having today has been done a number of times, as Bill said. And we brought to the table one time, I think that early on, that we thought that maximizing would be achieved by getting out of the standard episodic role that we did of research that we did on shuttle, and go into a station where you bring a lot of specimens and you do a series of experiments in an increment. And as I used to say to my graduate students, you could get, what I called an LPU from one increment. That's a least publishable unit. Okay, and so that you've done, or you've gotten very close to getting that completed. The second thing I think is even more important, and that is that I think the more onboard analytical capabilities that we have, the greater the throughput's going to be through space station. And irrespective of what level of science, I'm a cell biologist, immunologist type, so I like little bitty things, but even with people, and that size, the more that you can accumulate is ones and zeros, the more information we can get back, and we can get back without any down mass. You just need bandwidth, and that's it. So, and I think that if I had to make 2 recommendations, I've made the 2 recommendations. The second one is the one I'd really like to see us have to some level of fruition over the next couple of years. I know we've got a few things up there that we can do that with, but we need a lot more analytical capability there. And that will bring probably a stepfold increase, a log increase in the amount of information that's coming back.
Okay. Yeah, Lakshmi?
But when we
Wait a
talk
minute,
about
Nessa.
human being, I agree completely, but when we talk about human being, besides analytical approach, you should use experimental approach on the ground to be sure that it is safe, that it will work, and so on and so on.
Okay.
Yeah, but for human level imaging and things like that,
Yeah, yeah,
you know.
we'll get there.
It should be not or, it should be both.
We'll do both. And Lakshmi?
I just wanted to say amen. You know, we have been saying that for so many days. I think the one, you know, I'm a pharmacologist, and first of all, I have to thank Mr. Abbey and Mr. Burnett for bringing pharmacology to this level, because I've been working in this area for 25 years, and I think this is an integrated approach that I see everybody really coming. In fact, with the artificial gravity, if we can just do some PD, you know, models in your artificial gravity, I can tell you that, you know, if it simulates 1G, all the GI problems will be resolved, right? I mean, you know, so I'm all for it. But coming back to this, and that's how we will integrate things, you know, because I guess the gap we have now is the technology gap, because we cannot do what we want to do because we don't have the analytical technologies, we don't have the sampling technologies, we don't have the stability to keep drugs. So if we can really integrate everybody's, I guess, you know, analytical skills and the augmentation of sampling, that would be a key to moving forward.
Yeah, and Neil, I just wanted to paraphrase what you were asking. We need to be able to analyze those 3,000 proteins in our urine before we make it into drinking water.
There we go. Graham?
That's a really good segue to what I was about to say. So Neil, the other point here is you want onboard analytical capability that's being used in situ so you can actually be autonomous, because as you venture further out, you want the astronauts to be able to essentially perform their own personalized analysis. So that's actually, in my mind, an even more important reason for having that ability to have additional analytical firepower on the space station.
Okay, yeah.
This is a little bit different to this one topic. Is it okay?
Okay, sure.
Yeah, I have some kind of suggestion talking or discussing about this issue about maximizing scientific return from such and such. And then if we say scientific return, I think we have to divide purposes. Like I think usually we have two purposes. The one is for the exploration, like sending the human beings to the Mars type of issue. And the second one is the science in space. So that NASA uses the ISS like the national laboratory versus the NASA use for the exploration issue. And then if we think about some science return for the exploration category, then the information for survival for human beings is more important than to understand the mechanisms of the basic science. Mm-hmm. So that the physiology, psychology, crew ops, like Bill mentioned, like a survival issue or how to repair or how to fix the device or something like that is very, very important human factor thing. And telemedicine and autonomics. And information is more operational viewpoint, supposed to be. And as I mentioned, it's less science allowed, less basic scientific viewpoint allowed. So from this viewpoint, I was very much interested in John Charles mentioned about the small number of the subject, and then we have to return to the good old age that you did. Like even the small number needs to be appreciated, because when we send the human beings farther and farther and farther, we will have less and less number of the subject anyhow. So, but from the viewpoint of exploration, I think the few number of the subjects should be okay. But if we think about the science in space, then usually the conventional researchers, the scientists, requires a higher number of n numbers, so that maybe we have to think how we can increase the numbers in human beings or omics or the urine or etc. So I think my suggestion is, if we can divide the purposes into that kind, like at least two categories, then we can do some sharper discussions about the maximizing scientific return. And later, I will have other the kind of suggestion related to the science, how we can maximize the science itself in space.
Okay. All right.
That's what I think.
I just want to add, it's not, I think we're at a point now, it's not maximizing science, it is maximizing health. We're talking about long duration. It's not just science. We need to really look into how, with what we have and what we need, how we can maximize the long duration health.
That is exploration type.
Mm-hmm. Okay, that's good. Any other
I
questions?
would like just to add that actually to what Chiaki said, that and maybe it is our discussion at the same time, like the science is science, but actually during flight or during space studies, we have two kinds of studies, two kinds of science. One is what we were talking mostly today about. It is science which purposed to create the better condition, the better health and so on for human being, just to support flights.
Yeah.
But the other science, very important as well, it is science which justify our presence in space. When we use space for as a tool for science, like that's what you were talking about. That's what we're doing also, and it doesn't concern only very analytical study, but analytical as well, and systematic also, because we discover in this, like in this scientific studies, we discover gravitational mechanisms which are deeply hidden and we never knew about them, you know? So this is also science, and it is science which is the primary purpose is not to support cosmonaut, but to support science as it is, and to justify our using space and money for space.
Okay.
To me,
let's get another question in here. Okay. All right.
The two issues is important. Just a issue of the priority.
Absolutely.
So when we do something,
and they add to each other.
yeah, that's right.
Yep. Okay. Okay. Yeah, he's been waiting back there in the back. So go ahead.
Hi, I'm Alex Garino with Baylor Center for Space Medicine. I think one of the issues that was brought up in the previous panel was how much the scientific program is dependent on the flight program. And I'm wondering if maybe that's an issue that needs to be reconsidered, where a scientific program dictates the flight parameters. So throwing it out as an example, the issue of the high intracranial pressure. If you can do a high-risk short-term mission, so you're compensating for your high risk in which you do invasive monitoring, but you come down after 1 or 2 weeks, so you minimize the risk of serious infection, you could get the enough N and enough data where you can do less experiments because you see the changes in the results right then and there. And what Dr. Charles was saying earlier, that you're trading with longer duration missions, you're trading your N number. Maybe you could have a mix, so you could have 1-year missions as well as really short 2-week hops up and down that really match what the scientific maximization is about.
Okay. Anybody want to talk about?
Absolutely right.
Yeah. Okay.
And for some, even animal, even on ground, of course, you are absolutely right.
Any other comments from the panel members on this one?
Just to show how maybe science could help dictate how the way the mission is run, could also apply to physical sciences as well. And just an example, on Expedition 6, we were slated to fly through a solar eclipse shadow, but the day before we did a reboost and we missed it. And just as an example, if we could have just delayed the reboost until after the solar eclipse, then we could have collected some very interesting observables. So that's an example where you have an extraordinary, unusual physical event that you want to take advantage of, but you're going to have to change the way the vehicle is operated. And let me also say that we had opportunity to view the transit of Venus, and working with people on the ground, we were able to get permission and get the system to fix it so that we could see the transit of Venus on station. So you know, some of these things do happen, particularly if you ask, and the ground will bend over backwards to help you get these done.
Yep. Okay. Yep.
In maximizing the scientific return from the station, and here we're talking about using space to do science. In other words, not the exploration science, but the science in space. I'd like to hear people's opinions, and I know, Don, you and I have talked about this, but the level of scientific expertise that we're able to put up on the station. I'm fully aware of the tremendous training requirements for station crews, but nevertheless, when I compare the familiarity of Space Lab crews with their flights, Chaki, you're very familiar with this, and it was a very different situation, and so I'm wondering what people can say about how do you increase the scientific capabilities of the crew so that we can really take advantage of having people in space, not just pushing buttons, but actually doing some real science and using human intelligence.
Anybody want to address that? James?
I can start with the rookie view of this. So as one of those astronauts with a scientific background, and I think in common with a lot of my colleagues coming into this game, it was one of our initial surprises when we start to realize how we're going to become just technicians for most of these experiments. And our background is, we thought, you kind of feel uncomfortable realizing that you're not really going to be using most of your background. Well, but at the same time, you understand. Then you see the mountain you have to climb in training to get your driver's license just to be able to be eligible. And then once you're eligible, you need more training just to get there. So it is a trade-off and a matter of priorities. But it seems to me it's in the interest of this great trend towards autonomy that we keep hearing about as we're contemplating deeper and deeper space missions. This is yet another arena where we ought to at least push towards getting the crew to be using their brains more, if you want.
David, I've got a comment that I think is germane. We have some really, really sharp people in the office, scientifically sharp, engineering sharp, and after 5 to 10 years of being at NASA, they've forgotten the difference between entropy and enthalpy, and then they get on orbit and they're just technicians pushing buttons. We don't seem to have a way to allow these really bright, energetic, self-motivated people to maintain the skills that got them selected in the first place. And maybe with the launch rate that we have now and crews possibly spending 8 to 10 years between flights on the ground, we should have some means of our scientists and our research engineers to maybe work at the Johnson Space Center, because there's a lot of activity going on there where we can stay engaged. Maybe we could be a co-PI on a project, and we could publish a hors d'oeuvres. We could actually publish a peer-reviewed scientific paper en route to waiting this 10 years before we fly, and then when we get to space station, not only will we have the trained monkey skills of being able to push the button and get the banana pellet, but
Don't touch monkey. Monkey are excellent. Operated space. That's all we will tell you.
Yeah, but
More,
if you
sometimes more organized than cosmonaut.
but if you push the button and the banana pellet doesn't come out, then you need something other than a monkey to fix the machine, so that the next time the banana pellet will come out.
You took the words right out of my mouth.
Yeah, I would like
That's
to.
a welcome thing for
We're
us.
achieving integration here, whether you realize it or not, right?
Jeff, I would like to support what Jeff said. Because the limitation for, in space experiment are not only in technology, but the limitation are in non-standard life of those people who are living there. Different, absolutely different schedule, different relationship to relation to reaction on hypergravity, completely different countermeasures, and so on. So actually, the diversity of results is very big, and but at the same time, we had absolutely excellent experiment which were provided by Dr. Polyakov. And that was because he was a doctor. He had 6 people flying with him for 5-6 months, 2-2-2, with exactly the same program, so 6. And he was trained in our institute because he was worker at our institute before flight. I consider these results, which were obtained by our joint experiment with Austrian, which as experiment which will gain more and more power and understanding and appreciation from space community, because this experiment were real experiment as we understand, and the data are standard data from 7 people, including him, and provided by the person who knew what is important in schedule, in time life of cosmonaut, and so on and so on. But unfortunately, Jeff, that is the only, from numbers of experiments which is provided by my lab for 30 years, this is the only one.
Okay, let's get a question up in the corner.
So just a comment as a scientist that works in the lab but also has data coming down from ISS, 2,000 tests on astronauts already. And we typically, for most federal agencies we work for, we study the performance and biology of healthy people. And the question is, how far can a human go? And NASA's not the only agency needs to know that, okay? The Departments of Defense want to know it, Homeland Security wants to know it. What's the recycle rate in a human? How far can you push them? Under what kind of conditions? What's the limit? And that's really the set of questions you're asking. And duration of flight and microgravity is a key one. We have to be careful about, going back to the beginning conversation, that we could have them have gravity on them in sleep. We've not solved the sleep problem in space. We've just pretended it's solved. We give these drugs that are not intended to be given for short periods of sleep, and this is not a criticism, it's all we have and it works. But the chronic effects of these compounds at short periods of sleep defy anything we know about PK and PD on these drugs on Earth. So already we could look away from that and say, well, that'll do for a Mars mission, but we don't know that for a fact. The real issue here in human performance in biology is the dynamic over time, the trajectory of change, the rate of muscle loss, the rate of cardiac deconditioning, the rate of bone loss, the rate of neurocognitive change. And we need we need data samples from astronauts, and we need trajectories, mathematical models that will tell us how diverse those trajectories are becoming and what our interventions do to change them. We need the astronauts in this strange gray role where you're both, and Walt's not here because he would attack me, you're both a subject and you've given informed consent and we're bound by confidentiality rules ethically and legally, but frankly you're also a partner in the science. And because you got to be motivated, you got to do it, you're doing the experiment in effect for us. And later then, we want to share the data with you, but we can't put you in a situation where we've done harm by showing you you're worse than somebody else. So what we can often only do is show you your data. We still have to make an interpretation on it, and of course it's got to be blinded. I'm just telling you what the perspective is from a scientist who goes from the lab to the field in many different areas and has done it for 40 years for many agencies, and then back to the laboratory. Most frustrating for you is, why am I doing this? What is this stupid thing? And yet what is amazing is astronauts will do those things, and they do them very well, and they're to be enormously commended for their willingness to tolerate these outrageous things we ask them to do. But those data sets are useful, and these temporal trajectories are what we need. And that's why the duration of flight isn't important as the sampling rate and the reliability of the mathematical trajectory of the change in the biological system. That's what we have to use to go to Mars, because we're not going to have a practice run to Mars. And nobody in this room seems to have the will to do a 520-day study again. I haven't heard anybody say it. The Russians did it, God bless them, okay, but nobody else is going to do it. And 1 year is all we're going to give ourselves on ISS. So my strong advice would be, get a fairly reasonable sample rate down on what you want to measure and start using mathematical modeling, coefficients of change for each individual, and start looking at clusters of those rates of change and asking, is the intersubject variability large or small? What's that rate of change? Can we mitigate it? And then finally, and this is the hardest part, and this is my question for the panel, the frustrating part is these are not experiments. Experiments are what I do in the lab, where I control everything. What we do on Space Station or in NEMO and 520, those are quasi-experimental. We don't control everything else that's happening. We don't control the operations, and we don't control the other experiments. What we need to know in order to interpret the data is what else happened. What else happened that caused that blip or that change? Now, how do we get that information? Because that has been very tough to get from both NASA and other agencies. How do we find out so we can draw a timeline and say, oh, we know what that blip was. On that blip, they had a fire drill in the station or did this or that. And it's a major problem to line up that quasi-experimental variance with the experimental variance we're measuring across time and mission. That's it. Thanks.
All right. Yeah.
I think I have some the suggestion for both of, like to Jeff. I appreciate Jeff brought this issue. I have some suggestion. That now I think with that kind of time to train ISS astronaut from the generalist to the specialist. Like so far, the training is everybody does everything type of training. But now, like the Space Lab or Skylab did, maybe science operator or scientist type of the crew, and also the system operation or something like that, so that the specialist needs to be developed. That's the first one. And the second one is the, use the ground team or maybe the remote, the telemedicine, tele issue as much as possible, which means let the crew a part of the science community, like Don Petty mentioned, and let crew do something, and crew should let the ground people do it, to work together to make the science. And also, maybe should ask crew the easy ops. When we ask crew easy operation, then ask more data. Like if we ask crew to urine collection or the saliva or something like that, and then more and more data, so that we will have more database. So that's how we can increase the science output. That's what I think.
Okay, Joe?
Yeah, I have a question that relates to Chaiki's first category, exploration science. Using space station to get ready for deep space, and I include not only human physiology, but medical care and systems development as well. Although the panel may not want to talk about the latter. There are a couple different ways to plan this work. One is to get your requirements together and then implement them incrementally as the occasion comes up, which is kind of the way we've been doing it. The other way is to plan ahead 3 or 4 or even 5 years and isolate a number of increments necessary to get the subjects, select the right crew members, which allows you guys to become scientists and co-investigators, okay, and do the work in a consolidated fashion, with top priority being given to life sciences. They wouldn't be everything that's done, but they'd be top priority on the flight with the right hardware and the right crew skills for that period of time. Respond to that. Is that a good idea or a bad idea?
So what do you guys think about?
I think, well, one thing I'm seeing again from the rookie perspective, I hear these words the first time, payload, and expressions like we're flying an experiment, and then I think, this is not what we're doing. This is a laboratory. Its primary purpose is to research. We don't happen to piggyback on it and experiment. And so I think it's one of those paradigm shifts that we might want to operate. And with that new frame of mind, then we can envision the whole scientific program differently, and perhaps have the flight operations be not secondary to it, of course, because it remains primary, but be more accommodating to maximize scientific return. And that goes also with this idea of maybe not specializing crew, because we don't like that word, but if at least crews get to know all experiments on one particular topic or one particular system across the entire stack, then you just get more efficiency. And we all know how this works psychologically. The more you know and the more you understand about your job, then the keener you are and the more useful you are. So maybe it's just a matter of getting through this transitional phase.
There may be a way to get specialization without having to make a big deal out of it by just the way we organize any given crew on orbit. And just as an example, on our last mission, I took care of most of the food. And then Andre took care of all the water audits, and Dan here took care of most of working on the toilet. And so, you know, Dan got really good at fixing the toilet. And you know, if they would have given me or Andre the toilet duties, you know, the next time, just to kind of, you know, spread the goodness around, we wouldn't have been as efficient at fixing the toilet as Dan. Or the food, if they said, well, okay, Don got the food out last week, let's have Dan get the food out this week. Well, I knew where all the little bits and morsels were. I knew where the good stuff was. I knew where and so I could efficiently get all the food out so that everybody else could fix their meals and eat. And Andre was all over the water audits and the water sampling and analysis and could nail that down. And so these kinds of mini specializations, and we did this as a crew. I mean, our timeliners didn't do this. They would have just mixed all of these activities up. But we as a crew decided this is what we're going to do, and it improved our efficiency of getting our operations done. And so this could be something that crews before launch could decide, or it's just the short straw. Whoever gets the first toilet duty is the one that does it for the rest of the mission. However, and then you can save your other time doing the experiments. And the same thing can be applied to experiments. The first one that does the combustion experiment and nails down all the setup, that person does the combustion experiment for the rest of the mission. And the first one that works on setting up the SLAM-D mass measurement system, you know, that person gets it all sets up and gets ready for the blood draws. And so these kinds of specializations can give marginal increases in crew productivity without even having to go to the resort to actually choosing crew science specialists.
I'm sorry. I have a question actually, because I thought that this question, I mean, with Dr. Kerwin put forward, I thought that this question was very successfully answered on shuttle. Because why? I am not a representative of shuttle. I don't know what was going there, but in exactly 20 years ago, there was the 93. There was started the program Mir NASA, and this program started with shuttle flight on which they were flying 2 of our cosmonauts. And Charlie is here. He was the commander of that flight, and I was a PI of those experiments which were provided from Russian side on this station. And it gave me chance to see how it was organized, how was organized performance of my experiment on Charlie flight. It was organized exactly as you said, Joe. There was familiarization for almost 4 hours. I was talking with all people who were flying with him about the experiment. I told everything, I answered every question, and then the team was given time out to who of them would like to do this experiment, not to be a member, but to provide this experiment.
Anessa, if I can just add something to that. I was sitting here thinking, I think the biggest difference is magnitude. No, there is a huge difference, and it's magnitude of experimentation today. We cover 400 experiments over an increment, 200 or something like that. I'm not sure how we would have done it had we had the magnitude, the breadth of experiments to do on STS-60. We were able to do that because there was a small.
It looked great to me.
Oh, I know that. I'm glad to hear that. But what I'm saying is, we had a very limited number of experiments that were competed, and so we didn't get some of the stuff we wanted to do. We didn't even get to take. Or some of the things that we had on board we didn't get to do because the timelining was so restricted then. Shuttle was not it was not conducive to laboratory work the way you do on station. And I was so glad to see how station matured because I've never been there, but my understanding is a crew has the flexibility to do things as they see fit, spend as much time on it or as little time as long as they get the job done. Now that's my impression. I'm looking at Dan, looking at me saying, where did you get that idea? But that's the way it looks
Dan,
to us
here's the microphone.
from the ground. But I think what Jeff is saying is going back to, not Jeff, but was it Dr. Kerwin was saying, maybe, why don't we do it the way we used to do it? Because if you remember, crews for specialized missions were designated years in advance. Particularly any space lab mission, a crew was designated 2 or 3 years in advance, and they focused on that. I'm not sure you can do that with station because of the magnitude of what goes on. It's multiple space lab missions per increment, not even to mention multiple space lab missions over the life of station. I could be wrong, but I enjoyed it the way we did it. I'm not sure we have the luxury to do that with a crew today, but I'm speaking from ignorance, so Dan or anybody else.
Charlie, we did a lot of experiments that we didn't even train for because they weren't thought to even be on orbit for our increment, or experiments that were thought to be completely done on the increment before us, but they didn't get around to them, and now all of a sudden we're doing things that we had never been trained to do. However, we had the general skills to figure out how to get it done.
Okay, next.
Right here.
And then we'll let Dan talk. So. Go ahead.
I'd like to add a couple of different dimensions to the ones that Chiaki brought in. Scientific return, I think, also has 2 other elements which are quite important. One is funding for the next piece of science. We're in tremendous competition at the moment in all areas of science for funding. So what is the focus on the space station to make sure that this program, scientific program, can grow in the future? And the second scientific return that I'd like to see addressed is the question of the science that has public appeal, which provides the support, particularly from governments, which is critical for activities like the space station program. Thank you.
Okay. Anybody want to talk about any science that had public appeal?
Well, Gers, I was thinking the first part of that question is a Gers question.
And money is not, it's a tough thing, right, in terms of what research and how it gets funded, et cetera, right? And we're trying to balance, and you'll see me talk tomorrow at lunch where I'll talk about what I call exploration science, which is stuff we're kind of doing for our own purposes. Then I believe there's some other science that's more discovery kind of science. That's more what you're talking about, and we're really underfunded in that area. That's why we created the National Lab, and we're trying to get some commercial investment in that area. We have actually more capability, physical capability on station than we have money to utilize that facility. And so let's ask the other piece, which is a little bit the public. Any science that you got a lot of comments back when you returned that you thought that you were surprised by when you returned?
Well, first off, real science, peer-reviewed science that typically results in a publication in a peer-reviewed paper, when it's in the process of being done, is incredibly boring. And so, almost by definition, any...
Wait, I don't think you can say that to this crowd, right? They might differ with you.
But if you were to watch it being done, the process of the science being done is incredibly boring. Now, you as a scientist doing it or directing it from the ground may be barely able to sit in your chair because it's so exciting. But you watch it, and just an example, watch NASA Select for a while and see how exciting that is. And it's primarily because the subject of science being done is not very exciting. However, if you do science demonstrations meant for enticing students, you can make those really exciting. I brought a couple of knitting needles on my last flight, and I rubbed them with my Russian fur boot to put a charge on them, and there's a whole myriad of charge effects you could demonstrate that were really, really neat, and there wasn't any earth-shaking science in it. It's all senior high school science that you could see there, but it's free from the complications of gravity, and you can make some neat demonstrations. And these are the kinds of things, some of the things that Chris Hatfield did just with a wash rag, where he had a wash rag with water in it, and he wrung it out, and the water came out, and the surface tension wetting angle made it crawl all over his hands, and then when he let go, it all sucked back into the rag. I mean, that got like 1 million hits. And you couldn't publish a paper on that, but it engages the public because they see something that is sort of scientific, and you could talk about it, you could talk about the science, but it's really not the kinds of science experiments that get through peer review process and actually expand the progress of our knowledge.
It seems in general the public is more excited by research that leads to applications. Right, that have a direct impact, and that will remain always a major argument to successfully fund any project.
Yep, I think the application side needs to be seen. Dan, you got?
I guess one question also to you.
Sure.
We are talking now very freely, forgetting about one absolutely necessary condition. It is sharing.
Yep.
If we don't have sharing, but we don't, then we cannot do any science, because Professor Dinges was absolutely right when he said that whenever we got during flight, whatever fact, whatever data, we have to know exactly what this person, your subject, is doing, what is his schedule, what is his countermeasures, what is, I don't know, maybe very unusual situation which happened, and so on. We don't have sharing. And therefore, I know it because I'm very sorry about my American colleagues with whom I am colleague for many years. Bill is my colleague from 92, right? From 92. And we never cut our connection. We always work in spite of all the situation with Milresh, Caleb, with Bill, with Jacob, and so on and so on. But And I'm their friend, but I cannot, and I don't give them data about countermeasures of cosmonaut. And I know that they need it critically, crucially, because they don't know why out of 10 cosmonauts which they have, 2 are like excellent, the other 2 are like very bad, and so on. We know, but we don't know their data because they don't share their data with us. And I don't share with them the countermeasure which define very much in the fitness of cosmonaut. Whatever we talk today, everybody is talking very honestly and so on. But one question should be solved. If we will not solve it, there will be no maximize, nothing will happen. We need to have rules of sharing everything on International Space Station. It is our common station, and we have to be there common.
That's good.
And just to piggyback on that, Dr. Kozlowska, I think it's very important for all of us to remember we just have one space station and one crew. This was something that for our crew we kind of took to heart throughout. Sometimes it would be a little bit frustrating because all the science that was going on, and Charlie, you're right, about 200 experiments on the US OS, and the Russian segment typically 100 or 150 thereabouts. The problem is I have a hard time getting my mind around the fact that we even have segments at all, and I really wish that we had that we shared all the information, that we could double our sample size if we had cosmonauts participating in U.S. science and vice versa, and I think we really ought to do that. And it would give us the flexibility also to, on a real-time basis, be able to shift the workload. If we've got a certain investigation, we need a bigger sample size for it, then that becomes a priority then, but everybody participates.
Absolutely.
And so I think, unfortunately, we, the crew, probably have forced this in the wrong direction a little bit. As space station has grown, you know, Bill and Jim and everybody that flew in the early days, my goodness, 5-6 years to train to do a mission, that's an awfully long time. And then we've moved to single flow to launch, so we do it in about 2.5 years worth of training. And it doesn't give you a lot of time to learn all the particulars about 200 investigations or 300 investigations. So we have to use the skills-based training approach to be able to do the things we do. But we have driven it down to, we've cut the training down in half, and that's forced us, all the partners, to say, well, geez, we have so much that we have to teach Don and Dan about the U.S., keeping the U.S. systems healthy, that we can't afford them to be training on these other things. We can't afford them to be spending more time in Russia and vice versa. So there's probably somewhere in there a happy medium where we can get an appropriate amount of time where everybody can be trained to a skills level, we can share more data, we can have the real-time flexibility, stop thinking about this as 2 space stations, and have the real-time flexibility to be having cosmonauts participating in U.S. science and operations, and all the U.S. OS crew members participating in the Russian segment also.
Okay, and John Charles, you might want to say something about the 1-year increment. We're using the 1-year increment to try to do a lot of the points that Dan just made.
While he's getting the phone, I just want to mention, I think that's an excellent point, because the onus is on the investigators to make it as simple and useful for common across the board for everybody. I mean, if we make the procedure simple, and if you make whatever needed to be done, that's probably the investigator's responsibility to make it simple and easy and across the board and universal.
And that's what we're really trying to do, because we recognize the 1-year increment from the get-go. When I met with the Russian head of the Russian Space Agency, Popovkin, we agreed right up front that this was a unique data set, that it would be wrong if we didn't get this data set in the most combined, integrated manner that we could ever do. And we have kind of directed from on top all the way down into the organization to make this a seamless activity. John Charles runs a working group whose sole objective is to make sure we get the best data that's used for all of us out of this activity. Maybe we can take that 1-year increment and then carry that more into the daily 6-month increments and start utilizing the station in a more unified manner. But we'll see how that goes. Yep.
Yeah, no, I'm really glad to hear that, because shame on us if we're not sharing data. During the early expeditions, we did all experiments, Russian experiments, U.S. It didn't matter if you were a U.S. or Russian or any other nationality. You did all the science, and it's the way it should be. I really hope that we will go back to that type of an international space station, as we should.
Definitely. Yes, go ahead. Sure.
Let me a little bit return from data sharing to the wise message from Professor Dinges. I think that to maximize the return from ISS, we have to think about the trends that we find, the dynamic trends find in the extended space flights. The attitude of the community to the statistics is a little bit strange. They think that if you have 100 subjects, it's much better than to have 6 subjects for a year. So the first thing is to change the mentality and attitude. Trend, this what we do not have in most part of experiments in another areas of sciences. So let's respect this part of our research, that we have trends so we can predict what could happen. In the rest of the studies, it's so short that we do not know what will be the outcome of this event or some states in half. That's the first thing that he mentioned. Secondly, we can maximize return if we make simultaneous analog studies simultaneous to space flights. It's absolutely precise that sometimes I do not know what is going on aboard, but if I do simultaneous analog with mostly the same conditions, I can understand deeply what was going on aboard. So we can double the information doing analogs with the same schedule and mission protocol. And it's such a simple idea. Why we are not doing this? This is very strange. And if we return to the morning session, which is inspiring for me for the whole day, that they reminded us about the studies made in IBMP before the prolonged missions in space. We made analog studies simulating this particular combination of factors. So to maximize the data from there, we have to do analogs here. And thirdly, I want to mention the comment from Igor Savelyev. To share the data, we need research teams. We need trust. We need people who are ready to work together. And to do this, we need to do analogs. Now I have a very good research partnership with Professor Dinges, with his team. I think we can share data easily. It's not a problem for us. And we do not need to sniff each other thinking what a kind of spy he is and how he is going to interpret my data. So analogs are good because they allow us to establish that international research teams. And this is the way to maximize the results of the same team doing the in-flight study. So I think these 3 points are so easy and so clear, but we are not easy doing this. And I can't say why.
Okay, I have a comment. I heard some of the feelings about doing the daily work of research, and I can turn any of you into a researcher. I really could, so much that you'd really be excited about it. There's a school teacher here in Houston sent me an email. He said he'd work for me 10 hours a week for free. I said, come on. Within 1 year, he quit his job as a school teacher. He worked for me. He ended up with about 20 papers. He was a first author on a science paper. And another car salesman that had a chemistry background. He came. Within 2 years, he had a first author Nature paper and the cover of Nature. I could take any of you, you guys are so ambitious, I could take an astronaut and give you the excitement and the passion of research. I mean, that can be done. That would be like my saying, oh, being an astronaut is the daily work of an astronaut is really boring. Well, when you look at research globally, it is extremely exciting. You see things that nobody has ever seen before. You think of things that nobody has ever thought of before, and you end up doing it. So if there are people at NASA that would at Johnson Space Center, would like to come up to Rice for 10 hours a week, you'll remember what delta H and delta S is, and that won't be a problem. And we could, you might even quit the astronaut program and come back to Rice. And I can take physicists, chemists, material scientists, biomedicine, any of those folks. I think we could do that.
Can I have a question to the panel?
Yes.
And the
What? Yeah, how many volunteers would be willing to go? Oh, you got some. That's good. Okay, we had a question?
Yeah.
Yeah.
We have to prepare for the closure of the ISS and give the prioritization to the end of the ISS. And the gate is closing for some type of experiments. And I believe the most endangered is the human centrifuge. And because that's the one thing that the other vehicles cannot accommodate. The autonomy demonstration is good, but we can do it somewhere other, like Bigelow. But the human centrifuge is the one thing that only the ISS can accommodate. So the question is, do we have a good mechanism to prepare to select the the new experiment towards the closure of the ISS?
Правильно он говорит. That's true. He's right.
My comment is at a higher level, I think. I hope it is.
I think I'll just give a quick comment. Station is a finite resource. We don't know exactly when it's going to end, but eventually it will end. So we need to treat it as a finite resource and make sure we prioritize and we look at things and we take the maximum advantage of what we got with this unique facility. I think we're making tremendous progress in this last year. We need to continue that and see if we can continue to prioritize and make sure those unique things that only Station can do get done on Station. Go ahead.
Bill, I think one of the impediments to optimizing the return, particularly in human research, has been the national programs and the dedicated resources that went with each of the national programs. And it sounds like you're getting around some of that now. But for years, I saw, in my role as the IRB chair, HRMRB, I saw a lot of duplication in the studies and things that were being done that if I personally was asked, would I think that's the wise thing for us to do on Station, I'd say, no, we already know that well enough. But I don't know. That's a big issue to me, and I understand why they're national priorities. I mean, the funding's based upon support within each of the organizations, and they have different concerns. So I think that's a big thing for you to get around for this to be successful.
Bill, just a comment.
Yes.
15 years ago, when the station was kind of getting its act together, there was a lot of discussion about the plans for disposal. And the assumption that was made there was that everything was going to come out of orbit.
Who is it?
But that may not be the right plan.
Gosh.
And there were several proposals that were seriously talked about to send all the hardware the other way.
Mm-hmm.
And the space station could be a tremendous experiment for a propulsion event that would allow interplanetary travel. And why don't we get the Space Station Partnership and NASA off its ass and go do it?
All right. I like that. So we'll go. Yeah, there's no question that we should not assume that we're going to just deorbit the entire space station. We need to go look at the things that you've described and see what we can do with it and move. When we've talked about adding some electric propulsion and things for reboost, that could even be extended to continue station in some other area to move. So that's another unique way of I would call it recycling. So we'll think of another more creative way of using ISS rather than just our standard disposal. So that's an excellent comment. We'll think about that. Yes? Okay.
I would like to bring up 3 examples from my missions on the subject being discussed. One of them was a negative experience. Negative experience, I would say, probably brings you more lessons to learn than positive. That was my second flight to the Mir station. The time when IBMP scientists asked me to take with me detectors, those sensors, bubble detectors made in Canada, to measure radiation. They did not have time to certify them properly, and they proposed to take them as my personal cargo in my pockets. So I came up to Mr. Zelenshikov at Baikonur, who was my boss. I told him that a specialist asked me to take those dosimeters with me, and because they just didn't have time to do the paperwork, because we don't have enough of them on board. And Nikolai Nikolaevich looked at me and said, why is a cosmonaut putting together a scientific program for himself? And it was shocking to me to hear when the boss, a manager of flights, is doubting a cosmonaut. He is basically telling a cosmonaut that a cosmonaut should not be interested in putting together a scientific program for himself. Okay, the second example is a positive example. When we are a part of a cosmonaut crew, we do not fly every day. From flight to flight, from mission to mission, there will be a certain period of time when we are not actively involved in training and preparation for the following flight. We have a timeout. How to use this timeout? When Yuri and Malenchenko were on the same team, it turned out that I had one flight after the other. Then the third one, I basically had just enough time to rehab. There was just a very short period of time just to start training for the next one. So I proposed to use the time of the cosmonauts who were not actively involved for various reasons in preparation. They were not in the process of training for the next mission. I proposed that they could probably get some additional education during this time. And Yuri Gudzenko, he was in the mapping institute. Gennady Padalka was studying in an astronomy institute at that time. What was the result? I am flying with Gennady Padalka later on. That was my third flight already. It was the first half a year of the third flight, together with Baturin, Padalka, and me. Baturin already landed. He had a short flight, so Padalka and me on the Mir station. It was a large station already. We were working on a science program, and what do you think? How did we fill our business time if we had actually any 3 minutes over there? What we were doing? You know what cosmonauts are doing when we have some good view and no overcast, everybody's taking cameras and just taking pictures on the Earth and take a lot of photos. What we were doing, however, we were looking not for the installation part. We were interested in eclipse when it was night on the Earth. We were taking a manual camera out and we were watching stars. We were defining what star it would be. Here it is. Here it is going behind the horizon. We were measuring the spectrum of the star. That was a part of the experiment, and Gennady was especially interested in this experiment because this is something that was being developed at the institute where he got his additional education. So the result was, so despite not 5 stars got the measurements, but about 300 measurements that we got during our flight with good data. And so this is the result. So Gennady just got some additional education. As a result of that, we got much more output, much better, optimized scientific output from our flight. One more example. In July, we are going to carry out our next Congress of Participants of Space Flight. It will be in Cologne. And here I was trying to find a U.S. representative, Eddie Turnage. He is representing the U.S. side. He is organizing us together. Last year, we were meeting where? In Saudi Arabia. Andy was telling us that he, as an initiator of this program, was trying to carry out an agreement with NASA because he found a group of people who will develop a quite simple and effective and interesting interface. When in this video camera you can record something and you will be understanding very well what exactly you are measuring here. There will be the time, comments and everything, something to optimize taking pictures. This will be very useful in defining the orbit at which it was at, and turned out it was very difficult to persuade bureaucrats of NASA that it was a needed program and a needed development for in-orbit crew. They don't understand that astronauts and cosmonauts love taking pictures of the Earth. Problem is that any research on board needs to be popular, needs to be interesting for an astronaut. And if there is an initiative from a cosmonaut, that needs to be welcomed. That needs to be welcomed even before such cosmonaut or astronaut is invited.
Very small detail that Sergei was flying and he was not supposed to participate. To participate in our experimental testing of a new countermeasure device. But he got interested himself, and he did excellent addition to this experiment, which was started by Padalka, and then Padalka went down, and Sergei, just of his own, he asked, wouldn't you mind if I will do now the second part, and he did it excellent. And we appreciate his results even now, because you know that now we have made this simulator and it is on the board.
So I have a little bit different topics, database. And then my suggestion or idea is change the concept from the database to data use. And there may be different ways to use the data that we have already collected. And one issue is maybe how about to develop some kind of project like a human simulator, and then to collect the data we need anyhow data sharing. And then the database is developed, and right away the data, the base, such as life science database developed by NASA, is more individual-based database. But we can also develop some kind of a little bit different level of database, like a protein or omics or genes or something like that, so that we don't need to worry about whose data it is or something like that. And then when we develop develop the database, then the human simulator or omics simulator or whatever simulator, we input all of the data so that if we somehow it may be a little bit help for the issue like Dr. Dinges mentioned about to understand the dynamics or maybe avoid the duplication of the data like the Chuck mentioned, because the simulator has already integrated some data so that the people understand which data is missing. So data use is the one that we have to do, because otherwise data is just sitting in the database place.
Okay. All right. Yeah.
I think I have a general answer or comment to some of the questions which I think need some more answer, which is coming back to how to optimize the scientific return. My first is scientific return. Very often we say we develop countermeasures, and then we work on developing countermeasures. But I think in order to maximize scientific return, we also always have to know if a countermeasure doesn't work, if problem exists, we have not understood physiology. So usually the problem is much bigger. And what we do in space, we unfortunately have dirty conditions. We heard there are 400 experiments. Some astronaut is under sleep deprivation. The next astronaut eats a lot of high salt food, which, for example, have an influence on calcium. The next astronaut is stressed very highly, has a very high stress. And then we wonder why bone degradation is different in different astronauts. And we repeat it, and we do ground-based analogs, and the ground-based is a similar thing. So I think in order to maximize the scientific output, we also have to do another kind of analog studies or facilities, which says, okay, first we have some question of what's happening to bone, for example. We can do better studies. And then we have to standardize the conditions, standardize conditions for ingestion of salt, a condition of being stressed, of being sleep deprived, and so on, in order to really find out what's happening and also to know about the omics questions. Some astronauts may have some receptor deficiency and the other not. And so we have to come, in order to maximize scientific output, to the individualization automatically with all the consequences. And I think we are using, so far we are not using enough of this strategy. And that's basically the reason why I say we need not only analog facilities which replicate a mission, but also analog facility where we can standardize the question and find out the different influences to questions. And going back to scientific publications, I think we always have to be aware, at least in Europe. In Europe, many scientists who publish Nature, Science, and so on, and get the regular funding, they say, oh, those people here in space, they do phenomenology, they play around, and it's nice, but it costs a lot of millions of dollars. And so as long as we are not linking up enough with this community and really do top science under standardized conditions, we always have a lot of opposition, and this opposition is very strong. They don't give us hits on the internet, but they are politically very important. So I think we have to really address this community. In the United States, it's done. So you are models of how to do it, and but I speak in especially of Europe, and also we have to jointly internationally use these facilities which are available there. Thank you.
Excellent points. We see any other final comments? Yuri, do you have anything you want to say? No? Okay. All right. Just want to make sure. Yeah, maybe one more, and then I'll kind of wrap up with a quick synopsis, because I think it's 5, right? And we're supposed to stop at 5, or we can continue, or you guys can continue out while we're having refreshments. But go ahead.
My name is Peter Norsk. I'm the element scientist, the Human Health Countermeasure element at NASA. I'd like to follow up on Dr. Gerz's comment, and I'll do very briefly. You're absolutely right. It's extremely important that you connect with the outside world. And I think actually both in Europe and United States, people are doing it very well. and because it's kind of a requirement more and more. Now you have an applied program at NASA which you might think is dissociating itself from the outside world, but this is really not happening. That's why we have a lot of external researchers, we have research announcements, and in this way you include the external world into the space world. However, a future thought might be that you combine like NIH grants with NASA grants. This is not being done. This is separated in society because at this point people say at NIH, oh, this is space, this is financed by NASA. And therefore there's kind of a division this way. There's a political division. But we might think otherwise in the future to have our researchers doing both NASA grants and NIH grants in this way, linking the two things, because then you have more acceptance in the external world for what is done in space.
Okay, I think that's an excellent point. Let me just step back and I'll summarize a couple things I took away, and then you guys can talk in more detail. I think, first of all, the topic was scientific return from the integrated use of facilities and crew. What I got from this discussion is the word integration is much broader than I had thought when I first started this session. When I thought integration between maybe the partners of the International Space Station. But what I'm hearing here is integration is even broader. It's integration outside of our aerospace medicine community into maybe the traditional medical community, like here in the vicinity of Houston. It's integration not only from our research, but maybe into manufacturing, other companies that are building medical devices, other things. It's integration across silos. It's integration into the more rigorous scientific world, the NIH and NSF. It's a much broader term than I'd really thought of when we think before. So I think we're really limiting our sights if we think of integration as just international collaboration, international cooperation, and sharing data. That's absolutely important. That has to occur. But then I think we need to think how we break down even more barriers and we actually integrate even wider to gain a broader sense. The other thing I heard from this discussion is integration is not easy. When you integrate, you have to give up some of your requirements, some of your purity in science for the way you want to do things because you're cooperating with someone. That's a piece of cooperation. So you have to understand there'll be give and takes back and forth. I think that's important. The other big takeaway is I also heard that our data is very noisy, especially in the life science world. So we need to think about that. And is the noise so noisy in our data that the conclusions we're trying to get are going to elude ourselves no matter how big the end gets? And that's a topic I think you guys need to talk about and think about. Is there ways we can isolate some of that noise from the system and get by with a smaller N? We're not going to ever get the big Ns. When I was down in Galveston, the HRP group, they talked about how you can deal with low N. And essentially, there's many fields where the number of investigations are extremely limited just because the subjects aren't there. They deal with less than perfect science, but they still can get valid results. It may not be quite as rigorous, but it's still valid results. And there's some statistical things that maybe we ought to change in the way we do the end discussion. And that ought to be a discussion amongst this group. And then the last thing I'd close with is I think the thing I heard here is there's a tremendous amount of passion in this room. The questions, which are really not questions, there are many lectures from each one of you, are intriguing and interesting. But there's real passion behind what you're saying, and there's a real drive to take the maximum advantage of what we're doing in space. So what we need to do is take that enthusiasm outside of this room and outside of this group and get it to that broader community, to talk about the other medical community in this region, talk about the other engineering side in this region, and share that passion with them about what we're doing. We have a tremendous facility in space. It has a finite lifetime. It's up to us to use it the best way we can. One way of doing that is to integrate to the maximum extent, figure out ways to creatively use this facility, and we will get some really great results, and we're starting to get some great results. You'll hear some of those tomorrow in the alpha magnetic spectrometer world from Professor Ting. So there's some good things happening on station. Keep that passion up. Don't challenge it. Don't channel that passion towards each other. Challenge that passion out and sell what we're doing in space and sell what we're doing as an exciting activity that we're doing and let folks know what we're doing. And the crew patch prior to this one, they had a little motto, and it was off the earth for the earth. And I can't think of a better motto than that. So our research is being done off the earth But ultimately, some of this research, even our long duration things we're looking at, it's going to benefit folks here on the earth. It effectively benefit our elderly patients or elderly population. Some of the muscle things, bone loss things have direct application. So what we are doing, it has real application here to the earth, and we need to stress that piece as well. So again, thank you for a good discussion. Panelists, thank you for a very good discussion, and thanks for tolerating a slightly different format.